In this tutorial, I'm going to cover specific use cases using our lighting tools. This will include the light components, environment probes, creating custom projection textures, and using clip volumes to control what light can affect. I'll also be covering some features that were newly introduced in CryEngine 5.6. If you're looking for something specific, the list of topics that I'll be covering are listed in the description below, along with the video timecode where each topic starts. All of the material in this tutorial is covered in these 2 pages in the documentation on point lights and projector lights, including some additional information, screenshots, and examples. We did also cover quite a bit about using the lighting components in this tutorial here, which you'll find on our YouTube channel. So let's get started. We provide 2 light components. One of them is called a point light, and the other one is called a projector light. And I have a couple of them already placed to my level. You can put them into your level as independent components by going to the Create Object panel, Components, Lights, and you'll see 2, point light and projector light. We'll get to environment probe later. So what's the difference? Very simply, a point light is omnidirectional. The light goes in every direction. If I move this light around, the fall off is very obvious when it gets close to a surface, and you can see it's going in every possible direction. A projector light, on the other hand, will show its angle of dispersion much like our camera component with these yellow lines. So in other words, it can be aimed. In fact, it has to be. It can only be dispersed over a maximum of a 180-degree angle. And you set that right here. This one is now at a 30-degree angle. I can make it a really fine spotlight like this, or I can make it a very broad wash of light, but no larger than 180 like this. I'm going to begin by briefly going over the basic and most important properties that both of these light components have in common. And other than its position and orientation in space, that includes the radius, which is how far the actual light reaches. I'm going to turn off my blue light temporarily so we can just see how the red light is working. Of course, I'm setting the color right here through this property. If I turn this to none, the light will generate no shadows whatsoever. You may wonder what the usefulness of that is, but I'll show you some use cases. If you want to ensure that the light casts shadows and everything, you're going to want to set your minimum shadow graphics to low. Attenuation bulb size controls how large a radius in which the brightness of the light is 100%. The default value is 0.1, but if you want a light like the sun, which is effectively even across a large area, you could set this to a larger value. I know everything within a 10-meter radius is going to be the full brightness of the light, and then it's going to fall off to 0 when it reaches 20 meters. If you're using volumetric fog, you can control whether the light affects the fog or not. I do have a fog volume here. I'm going to make visible. Turn down the density somewhat, and now you'll see the effect that this has. So you can actually have a light that illuminates things except the volumetric fog itself, if you so desire. You can toggle whether the light uses the global illumination, the SVOGI system or not, dynamically or statically. You can have animated lights, so if you want them to pulse in terms of brightness or in terms of color, there are many, many animations created here, which you'll find buried in a shader for those of you technically inclined so that you can study them and modify them or create your own. For most people, you're going to find most everything that you need for animated lights. And now we get to something that was introduced in 5.6 that's buried all the way down here at the bottom of the point light component under this thing called shape. And what it lets us do is instead of the light emanating from a point that actually has some size, it's not infinitely small, but we can let the light emanate from a larger surface area, which is either rectangular in shape or circular in shape, or actually ellipsoidal. The size of this can be up to 10 meters. So now effectively, the entire surface of this rectangle is emanating light, or in the case of the disk, the entire surface of the disk is emanating light. This kind of mimics what a soft light in the real world does, which happens if I shine a light onto a white wall, for example, or some kind of bounce matte surface or shiny surface, or if I pass a light through a translucent material. If I light it evenly, the entire surface effectively becomes a light source. However, in the real world, light beams scatter in many, many directions, creating slightly different shadows, which all mix together and make a soft shadow. We don't do that in game development normally because it's already very expensive to calculate shadows, and if we were calculating millions of them per light, the game would just grind to a halt. So, in fact, the first thing you need to understand about these area lights is that you cannot use them with shadows. The first thing we have to do is turn off shadows. Otherwise, it's just acting like a point light. And now you'll see a marked difference in the way that this light seems to work. You'll see a very clear line, and you can see, in fact, that the whole thing is emanating light perfectly evenly. However, there's a little tricky factor to setting this up correctly. If you do want the entire surface of your rectangle, your disk, to emanate light evenly, you have to set the attenuation bulb size to at least the diameter of the disk of the rectangle. I'm going to show you what I mean. I'm going to go back to the default size of 0.1, and if I move the center of this light very close to the surface, you'll see that in fact the light is not emanating evenly from the entire rectangle. It's emanating from a point and quickly falling off. If I change that bulb size to match the size of the rectangle, 10 meters in this case, then the entire surface is now completely evenly emanating light. And that is the correct way to set up what we call an area light. Now, you may ask yourself, in what cases may I use lights like this if they can't cast shadows, which indeed area lights can't? Well, it turns out they have a lot of uses, and I'm going to show you some various examples. But one of the things they do really well is create beautiful reflections in the entire size and shape of my area rectangle or my disk. And you can see that in the shiny surface of these objects that I have sitting on the terrain. Very realistic reflections, as if coming from a big soft light source. So I've created a scene here with a building you may recognize as the hangar from Game SDK if you've ever installed it. I'm not using a Game SDK build, but I did unpack some assets from that so I'd have some models to work with. So right now I have the time of day set up for daytime, and it's pretty easy to see in here. Of course, I could add some fill light and that sort of thing. I've got some sunlight coming in. I could use my Sfogy to add some fill. What I want to accomplish here is something more subtle. I want to make this look good as if lit by moonlight. So I'm going to change my time of day to something very dark, like this. And you notice that I have my sun intensity very, very low. So effectively, that moon is visible because it's glowing, but it's not emanating any light to light my scene. So if we go inside the hangar, I've got a couple of fires burning so we can at least see what's going on, using particle effects, of course, that also have light components. But I want to get a sense that the moon is lighting this hangar. So there are a couple of ways to do this. I could actually use projector lights and shine them in the windows. But what I'm going to do first is use these area lights to create a very subtle light and a really great reflection on the floor of the hangar. So again, the way to do this is just add a component, point light, bring this in here. I'm going to make the radius quite high. In this case, I would also go for something more bluish. It's going to feel more like night because we perceive it to be darker than warm light. We cannot use shadows with area lights. I want my attenuation bulb size to match the size of my rectangle, which I'm going to make the maximum size of 10 meters. So that's what my brightness looks like right now. By the way, you'll notice that by default, the area light only emanates from in one direction, but you can change this to two-sided right here in the shape settings and have it go in both directions, which is useful in some cases. You can also project textures just like you can with projector lights. And I often find that that's useful for breaking up that simple wash of light with something that feels more organic. Later in this tutorial, I'll show you how to create a custom texture. So what I'm going to do is, first of all, rotate this light 180 degrees, because I'm going to make it come from the side of the scene where the moon is, which is out on this side of the building. And what I want to do is line up my rectangle so it coincides with these windows. I'm literally going to put them in the windows. Now what I want to do is match both the position and size of this window. And to make things a bit easier on me, I'm going to grab a temporary work light and pull it out here so that I can see what I'm doing because it's so dark. So there's my rectangle. It's too tall. I'm going to try bringing it down so it kind of matches the size of the window a bit better. I'm going to temporarily pull it outside here so I can see. So that's approximately the size that I want to have. Now what I'm going to do is move it inside. I don't want light on the outside of the building. I'm going to turn off my work light. I'm going to set my attenuation bulb size to the same size as I made my rectangle shape. And now it's a matter of tweaking this light to be as bright as I want it to be. I want it to be quite subtle. So I'm going to use a fairly low value here. And there we start to get the idea of that moonlight glow. So I would repeat that process for all of my windows until I end up with something like this. And if we take a walk through the hangar, you see this really nice subtle glow on the floor and the surfaces of the hangar. Feels very much like there's moonlight coming in there. You may also want to tweak in your environment settings so it's not as dark as I have it right now. Thing like that. So it appears that the moon is actually lighting the windows themselves, and that matches the glow that we're feeling, and we see the glow outside the windows. So that's one use case for which I find area lights to be very useful. If we look around this hangar, there are some other examples. I've actually made use of them in a lot of places. So this little hanging token, for which I made a flow graph script to swing as if in the wind, is completely lit by area lights. If you pull out, you'll see that I have a particle effect of a fire burning in a barrel here. And the idea is to motivate the source of this warm light on the foreground of these objects. And what I have is an area light aimed just like that with a very warm color similar to fire. And I've used the animation property right here. And animation 34 looked like a pretty decent flickering effect to me, though I did end up slowing it down to 20% of its original speed. Then I have an area light like this right behind it, which is set to this sort of blue-green color at a very low intensity. And that's what's creating this sort of edge light on the skulls, simulating moonlight again. Here's another example. I have an entity here which is like an oil drum. And if you notice, I've got some fire particle effects inside it, but I also have this gleaming moonlight on there that seems to be coming from the sky back there. But in fact, this is just another area light, sort of positioned to mimic what the moon would be doing. And a good place to start when you're going to rig one of these is actually to turn up the brightness of the moon and see what it actually does on there. The reason that I set it up this way is I don't want the moon itself to be bright, because the moon itself is just a texture that glows. But it's the sun positioned directly in front of it that emanates light. And as soon as I turn up that brightness, I'm going to get the effect of the moon disappearing behind the sun that's layered on top of it. So to get a more realistic night sky, I keep the sun intensity down to 200 and below and supplement the scene with selective moonlight as needed. Now, of course, there's an issue here, which is that these little bits and pieces of fake moonlight are sporadically lighting the terrain and so forth. And if someone's really paying attention, they're going to start to notice this. So in this case, if I just want to use this to get that kind of gleam of backlight on this object, I only want it to light the object, and I don't want it to light anything else. And the answer to doing that is something called a clip volume. You'll find these under the Create Object panel, under Area, Clip Volume. And if you go to draw one of these by default, you'll find that they can only be boxes. If you've ever used the Designer tool, this will be very familiar to you. Now, the fact is that once you've got this thing, you can click on the Edit button and the Designer tool will pop up and you can draw anything in addition to the box. So I could come up here and say, well, I need a cylinder to mimic the shape of the oil drum, and it's something like this, and I'm good to go, but I don't need this thing. Well, the problem is, if I delete the original box, my other object is going to go away too. So the solution when you need custom clip volume is to actually model it in the Designer tool or your DCC tool. Keep it simple, don't use more vertices than you absolutely need to, and then export it as a CGF. Because you'll notice here when you select a clip volume, there's an option to load a CGF that you've already made. So what I'm going to do in this case is just take my Designer tool, and I'm going to model a simplified version to mimic the size and shape of this cylinder. And I'm not going to worry about getting it too accurate. I know it's about 4.7 meters in diameter, something like that. And I've snapped it to the terrain. I'm just going to pull back and more or less match the height of this thing. Now, just to check that it's the right size and shape, I'm going to go ahead and link it to the tank. I've got Keep Pivot Centered turned on, and now I can go to my relative coordinates and transform and line it up exactly and see how it lines up with the actual tank, which should more or less disappear inside it. Once I'm happy with that, and I can go into my Designer tool and modify it as necessary, then I'm going to go ahead and export it as a CGF. So I'm going to go to Designer tool, Transform, Export, CGF, and I'm actually going to put this in the same folder as the oil tank model. I'm done with the Designer object, so I'm going to go ahead and delete that. So now I'm going to select Create Object, Area, Clip Volume again. I'm not going to draw anything. I'm just going to click on the Load CGF button. I'm going to go back and find my object that I just made, and I'm going to close my Clip Volume tool. Now here's where things get a little bit confusing and mysterious. Where did it go? I can see that it exists. It's on my current layer. It's called Clip Volume 3. But if I select it, and if you look at the position, you'll notice that by default, it's going to snap to 000. So if I click my G key to go to it and pull back on my scene here, I don't even know if you can tell where I am, but I'm basically underwater off at the corner of my terrain. I'm going to go back to where my drum was. I've got my clip volume selected, and I'm just going to Control-Shift to snap it to the terrain. I'm going to rename this thing, and I'm going to go ahead and link it to the tank so I can center it. So there's my clip volume. If I turn off filled, I can get a better idea of how it looks. I've got a more complicated polygon mesh that I needed here, so I could have worked harder on it in the designer tool, but this is good enough for now. Okay, so how do I make use of it? Well, what needs to happen is I need to link any lights that should be constrained to this to that clip volume. By the way, you'll notice this line here. That is not the kind of link I'm talking about. That's just a parent-child relationship between the oil tank and the area light so that I can easily move the tank and everything else will move with it. What I'm talking about is selecting the light component. So there's my area light. I'm going to go to Entity Links, click on the Pick button, and click on this clip volume. So I need to find a place where I can click where the name of the clip volume will pop up. And now it appears right here. Very important, don't forget to close the Pick Object tool or nothing's going to happen. That's tip number 1. Tip number 2 is you've got to turn on Only Affect This Area, which is actually on by default. And that means that the light that is outside the clip volume but linked to it will only appear inside the clip volume or on the objects that are inside it. You can also just put a light entity inside a clip volume with this enabled, and it'll automatically be constrained inside the clip volume. So I'm going to turn up the brightness of this light temporarily just to make it very obvious that in this case it's not yet working. So the last tip is, in order to force CryEngine to recalculate using this clip volume, you have to toggle the light off and on again with the active property. Again, I want to make sure Only Affect This Area is turned on. I've got it linked to the clip volume. I toggle active off and on again, and now you see that the light only appears inside that clip volume. And in this case, you also notice I did a bit of a sloppy job with the designer tool, made it slightly too large so it's spilling onto the terrain. An easy fix for that would simply be to move it up so it doesn't touch the terrain like that. And I'm going to go back to my object, turn my brightness back down to where it was, and there's my moonlight effect. Here's another use case. In addition to lighting the inside of the hangar with area lights placed where the windows are, I've also placed a bunch of area lights up high to get this nice gleam on the roof for purposes of a cinematic track view sequence. And since these lights don't cast shadows, you can go pretty wild with this and create huge arrays of full-size 10 by 10 meter area lights and use them to light very large areas with this subtle kind of light. It's very useful for supplementing sunlight and moonlight inside buildings where it would otherwise be really dark. So if I wanted to have some sharp beams of moonlight coming through the windows of this hangar, what I would do is create some projector lights, which I've done right here, and put them outside the windows so they're approximately shooting at the same angle, like this. I'm going to give them quite a large range, and I'm going to give them a very large attenuation bulb size so there's no fall off across the hangar. Because to be consistent with sunlight or reflected sunlight off the moon, I want the intensity of the light to be even all the way across the surface here. I'm going to go ahead and make these active. And now you see I have these nice shadows of moonlight coming through the windows down there. But what's tricky about this is that I've used that clip volume again, so you'll notice that there's no light on the outside of the building. If I select these things and I turn off this Only Affect This Area property, there's what I'm talking about. I turn this up temporarily so it's nice and bright. That's what it would look like if I didn't have it linked to that clip volume. And again, that clip volume is that blue shape that you see surrounding the hangar. That's it for area lights. Let's go back to our projector lights and take another look at those. The first trick I want to tell you is if you double click rather than drag on the projector light component, you have the ability to rotate and aim the light with the scroll wheel on the mouse as you're positioning it. Once I've got it into place here, I'm going to give it a bit more range. I'm going to give it a very obvious color. And I'm going to make it considerably brighter. So, unlike a point light, this has a direction. It has an angle of dispersion. And something that isn't exactly obvious is that it also has a texture, even if you leave these projector options, projected texture, empty. If you put a projector light very, very far away from a surface, you'll start to notice the pixelization because the texture that you can't see here is only 512 by 512 pixels across. You can make your own, or you can select from those that we've provided for you, and you'll find those under Textures, Lights, Generic. And these include some exotic ones like the ring lights, circular spotlights with hard or soft edges, and various rectangles. So let's say you want to make your own texture. One of the tricks that I like to do is break up this light and make it not so even by giving it some imperfections as if it was passing through a lens or bouncing off of a surface. This is very simple to do. I'm going to go to Photoshop. I'm going to make a new file. I'm going to make it 512 by 512 pixels. You can make these light projection textures larger. However, as you know, every texture consumes memory. And in most cases, you'll find that you don't need it to be larger than this unless the light's going to be really far away from the surface. So I'm going to stick with 512. We want to use 16-bit grayscale. It doesn't really matter what color you fill it with. It's going to be a shade of gray anyway, and we're just going to end up replacing it. I'm going to make a cloudy spot with a 5-pixel softened edge. There's my texture. So I could come in here with a brush. Since I started with middle gray, I could take black to darken and white to lighten. Anywhere there's white, it's going to reveal the light. Anywhere there's black, it's going to block it. And gray is somewhere in between. But an easy way to kind of make some textures is to use these render filters, including clouds, which you can do over and over again until you see one that you like. Just choosing this over and over again. It's randomized. And you can also build on this and refine it by using difference clouds. And again, I can keep repeating this and it'll continue to evolve. You also might want to consider adjusting the tonal range of this, which you can do permanently using image adjustments like curves or levels. So if you don't want full blockage of anything, you can get rid of the blacks like this. Or if you want more of a high contrast texture, you could move your endpoints inward and get something like this. I'm going to kind of soften this effect and make sure that I've got some pure white in here so I definitely get full intensity of light and nothing too dramatic, so the texture stays quite subtle. I'm going to go File, Save As, and I want to save it in CryTIff format. If you don't see that here, then you need to install the CryTIff plugin first. I'm going to go ahead and do that. I'm going to save this on my desktop for now and exit out of Photoshop. So if you go into your build folder, which you can find through the launcher by clicking here and saying Reveal in Explorer, you want to go to the Tools folder and we want to find this guy, CryTools Installer. And I'm going to go ahead and install the Photoshop plugin and uncheck everything else. And this happens so quickly, if you blink, you'll miss this little message that says Success, because it's just one tiny plugin file. And we're done with that. Once I've got that installed, I'm going to go ahead and run Photoshop again. Reopen the file, File, Save As, use CryTIff as my format, and I need to put it in a folder within my Assets folder so that my build can find it. When this dialog box comes up, I need to choose my light projector. Click OK. I'm done with Photoshop. If we go to the Asset Browser, go to my Textures folder, there's my texture. So to make use of it, got my projector light component selected. I'm going to click on Projected Texture, browse to the custom folder I just made and the texture I just saved, and there it is. And now if I move that light around, you'll see that it has this kind of nice organic effect. Now there's one suggestion I'd make about these textures is that you probably don't want these hard edges to them. So to avoid that, you're going to want to feather the edge of this texture off to pure black. So let's say I want to do a circular version of this. I'm going to select my circular marquee tool, and instead of normal, I'm going to choose a fixed size. I know I have a 512 by 512 pixel canvas here, so I'm going to choose something, let's say 490 pixels. And I'm going to Alt-Shift-Click to create a perfect circle from the center of the texture. I'm going to go Select Modify Feather, and I'm just going to choose 5 pixels. If you want a softer edge, then you should blur it more. I'm going to invert the selection, which is Select Inverse, and then I need to fill this with black. What I'd like to do so that I'm not messing with this texture is to keep it on a separate fill layer. So I'm going to do Layer, New Fill Layer, Solid Color, and I'm just going to call this Black Edge, and I'm going to fill it with pure black. To double check this, you can use your eyedropper in point sample mode, so I'm measuring the color of a single pixel, and zoom to these edges here, and just roll the mouse over there and take a look at your info palette and make sure that these reach 100% K, 100% black, or 000 if you're looking at your values in terms of RGB, or 0 brightness in HSB mode. And now you notice that I have a circular texture and it has a nice soft edge. And that's how you create custom projected textures. So here's some examples of projection textures used in different ways. I have a blue projector light back here that has a very subtle blurry texture on it, like the one I just showed you. I have a point light right here, which also has a texture assigned, which happens to be a scanning electron microscope image, but it's very subtle what it's doing as a point light. But if I change it to an area light like this, suddenly it becomes a very different beast. And you can see that I'm getting this really interesting reflection. I've also got these objects animating. All they're doing is rotating slowly, like that, through flow graph. And now we start to get some pretty interesting stuff happening here that you might not expect to see. And just to restate that you wouldn't want to use a sharp projection texture, even one that's 1024 pixels like this one, if it's going to fill a larger pixel area of the screen than the resolution of the texture itself, because then you're going to see these pixelated artifacts like this. However, if it's going to be used in a smaller way, you can do all sorts of interesting and unexpected things with these projection textures. Here on the back wall, I have a simple kind of window pattern that's projected, like theater gobos. Here, this is an actual image. And if you look here, I have several different images. I'm going to start over again. This is what it looks like before they all start moving. I've got one projected from above by this sort of video projector model that I built down on the floor, which is another microscope picture, and 3 more microscope pictures projected from similar devices here. These are all just projector lights with textures. So if I select one of them, you can see there's my color. I've got shadows on, and I have my projection texture right here. These all happen to be 1024 by 1024 because I'm using kind of sharply focused pictures. And here's what they look like once they start moving. And here's an actual fly-through of this level with all this lighting overkill going on. And this is all real-time stuff. You can see I also have cloth entities, all casting shadows as well. You're seeing these light patterns moving across the cloth is a pretty interesting and dynamic thing. The last use cases that I want to talk about are actually putting light components in some kind of light fixture. So out of the Game SDK assets, I've pulled this street lamp. And if I turn on this work light here, we can take a close look at it. We've got the post, and up here we've got a space to put a light bulb. I don't have an actual light bulb model. So what I would do first in this case is add a projector light, literally up inside this thing, like this, centered, aiming downwards, and then I can adjust the angle, the range so it reaches the ground, the color, the brightness, and enable shadows most likely. However, if you look at this closely without the helpers turned on, you'll notice there's something disconcerting about this, which is that there's no light actually inside the housing for the bulb, and there's no bulb glowing in there. You could go to the trouble of building a glass model for a bulb, although in many cases you may not need to worry about it because the player is not going to look at it. What I would do to fix this problem is just take a point light like this with a very small radius, just big enough to illuminate the actual housing here. You want to avoid having to cast shadows with this point light source here when you're just using it as a glow. The better thing to do, in my opinion, is just to use a glow texture on the inside of a lamp housing like this. And in fact, if you watch the other tutorial where I lit this hanger, you'll notice that this fluorescent light fixture uses exactly that. There's a sort of a metal housing here to hold the light, and this is just a simple surface with a glow texture, and then there's a projector light placed just like that with a rectangular texture. And that's how I'd build it in most cases. Next, let's dig deeper into the business of reflections, environment probes, and global illumination. I don't have an environment probe in this scene yet, so there's nothing to calculate proper specular reflections. But let's take a look at what we have before we add one. I have 3 pairs of spheres here. One pair has a shiny metal material that'll show sharp specular reflections, like this projector light that I have right here. Another one has a stone material or wood material that is not going to show any kind of specular reflections. And the third one has a brick material that's shiny enough that it'll show a little bit of specular highlight there. Now, if you look closely, you'll see what you may think is global illumination. You'll see this kick, which is coming from the terrain right here on the bottom of this sphere. But a funny thing will happen if we come in like this, or if I just pull back and tilt my camera up, it mysteriously disappears. So this is what's called SSR, or screen space reflections. And literally what it does is just use whatever is in the viewport at this moment, moment by moment, to calculate reflections, kind of like poor man's ray tracing. It's not quite ray tracing, but it tries to achieve some of the same effect at a lower cost. So obviously that has some limitations. And you can see here that my global illumination is off right now in my environment editor. By the way, you can toggle screen space reflections on and off with this CVAR. So if I turn that off, you see that kick disappears. If I turn it back on, it comes back again. Normally you're going to want to leave it on. Let's look at another aspect of reflections. I have an area light set up here, this yellow thing right here. You'll see my rectangle there. It's 10 meters by 10 meters, so it's quite large. I've got my attenuation bulb size also set to 10 meters, so it's completely even across its surface. However, my radius is only 2.6 meters, which is why it falls off before it reaches the edges of that. So you'll notice something here, which is that none of these spheres, not even the shiny one, are reflecting, nor are they illuminated by this area light. So if I go ahead and select that light, and I'm going to go to an overhead view here, and I start changing this radius, you'll see that the radius of the light starts to touch the middle sphere and eventually is going to touch the other spheres as well. But what's interesting about this is you're going to see suddenly a reflection. This is a reflection of that entire area light area. But if the radius of that light entity is small enough that the light itself doesn't touch the ball to illuminate it, it also isn't going to reflect it. It's called. And of course, this is for performance reasons. So it's a really important thing to understand. So even though realistically this should generate specular reflections of this light surface, again, the radius has to be large enough to include the actual entity that you want to do the reflecting in order for that reflection to show up. So let's go ahead and add some proper specular reflections using an environment probe. Environment probes generate cube maps, and all that is 6 pictures looking up, down, left, right, front, and back of the current scene. So you'll find these in the Create Object tool under Components, Lights, Environment Probe. And I'm actually going to go back to a scene that I already have set up here that has a bunch of projector lights, a bunch of shiny balls in it, and moving cloth, and even some particle effects. I'm going to put my environment probe pretty much in the middle of this thing. So I'm going to kind of eyeball it with the box here so that it's between these walls that I have. And I can use my scroll wheel to sort of rotate it, something like that. And normally I would recommend putting it around eye level to the player. Also, I want to expand this to make sure that it includes everything that I want potentially to be reflected. And that's going to turn out to be about 29 meters. So you can see the box goes off through these walls that I have on either side of this scene to sort of constrain it. Then if I want to really get crazy and even reflect things as far away as that, I could make this box really, really big. But in this case, I'm not going to worry about making it any bigger than the entities I sort of have in this immediate area here. That 50 meters should be more than enough. And I'll make it a bit taller. And before we actually generate our cube maps, I want to go down and find one of these balls that has the shiny metal surface. And you'll see what looks like a specular highlight. Again, that is because the purple projector light coming from that projector that I modeled right there is actually striking the ball. And so it's reflecting the light source itself. But for example, I don't have reflections in the ball of these lights that are being projected through a circular texture onto this wall here. So now that you've seen what it looks like without the environment probe, let's go ahead and generate our cube maps. I've got my active property on. I don't only want to affect this area. In this case, I don't have a clip volume set up, so it's not relevant. And I'm going to go ahead and click on Generate. This will take a few seconds. And now if you look closely at the ball, you'll notice that we have a whole new set of reflections here, which includes these lights reflected on the wall behind me, right back here, and also the logo texture that I have projected on the floor back over there. So the general rule of thumb about environment probes is pretty straightforward. Every level should have at least one global environment probe. You can simply put it right smack dab in the middle of the level and make its box size as big as the terrain height map. Another tip, which I actually forgot to do, is before you generate these cube maps to actually name your entity properly according to your studio's naming scheme, because that name is going to get included in this TIFF file, this cube map that gets saved, along with _CM for cube map. Now I'm kind of stuck with it, so it's not an ideal situation. I can go ahead and rename it now, but the cube map isn't going to be affected by that. So now that we have our environment probe, let's tweak things a little bit. We can go ahead and turn out the specular multiplier. If we want really sparkly kind of highlights there, we can get an effect like that. I'm going to tone it down, maybe something like this. Another thing that we can do is crank up this diffuse multiplier and essentially use the environment probe as a fill light. I have pretty heavy fog in this level right now, so I can also choose not to affect the volumetric fog. And you'll see that I'm just essentially using the environment probe to sort of scatter light everywhere. You can go crazy with this and even set a color. So for instance, now I've got a crazy red, and you see how that's reflected everywhere. For now, I'm going to go ahead and leave this set to white and leave my diffuse multiplier set at its default values. So we've got our environment probe set up pretty well. I'm going to go ahead and save my level. And now I want to point out one of the most important things about these, which you might have already inferred. I'm going to turn on my physics, which is also going to enable a flow graph script that I wrote that animates my projectors. The projectors are just boxes with a little fake lens, a glow texture in the front, and a projector light component attached to them, and they sort of bounce around as if affected by the wind. So you can see that the lights are moving, but what you won't see is the texture changing. This texture that's reflected isn't actually coming from what's happening in the scene right now. It's coming from that TIFF file that was generated when the lights weren't moving. In other words, this is baked. These cube maps are static. They aren't dynamic. So there are limitations to what you can do with this. So now that you know that these cube maps are static, what do you do in situations where the light changes during your game? Well, let's say you want to switch times of day. You've got a night scene set up. You've got a level set up for day. Maybe you have one set up for magic hour. Every time your lighting changes, whether it's sunlight or light components, you need to use a different set of environment probes. So what you end up doing is creating multiple versions of all of your environment probes in each location and simply toggling them on and off when your lighting changes. It's a very common thing to do. We use it in combination with layer switching, which you can control through FlowGraph or through code. And we use the same approach in our latest game, Hunt Showdown. This obviously is imperfect and doesn't solve the problem of reflecting things that move around during the game or the use of dynamic time of day. Hopefully this also helps you understand why we've put a high priority on integrating ray tracing into the engine, as you can see in our Neon Noir demo. This technology is scheduled to become available in a future release of CryEngine.